Okay, so this if you want to look at the theorem, right, for this in general, if you are looking at any theorem, we will look at the condition and the result. So these are the two things that we look for in a theorem. So like Pythagoras theorem, we look at the condition. The condition is 90 degrees, then we got the Pythagoras theorem, a squared plus b squared equal to c squared. So in this case, right, if we are going to be looking at the midpoint theorem, we also look at the condition. Okay. So there are two conditions to satisfy. So the first condition is I'm going to label the triangle as midpoint first. So you need to have the midpoint that is on the right side. So M is the midpoint of AB. So to me, visually I see as I got the midpoint on the right side of the triangle. So you can think of it this way. So you got the midpoint on the right side of the triangle, and you also got the midpoint on the left side of the triangle. So you also got the midpoint on the left side of the triangle. Okay, so this will be the two conditions that you need for this theorem to work. So if the question starts you with feeding you the midpoint, then you might want to think, so does that match the condition of the midpoint or not? So the idea here is if I got these two conditions, then I will have two results. So if I got these two conditions, I will have these two results. So result number one will be MN. MN is actually parallel to BC. So if I got these two ingredients, you can think of it like ingredient. So the midpoint on the right side and the midpoint on the left side is like an ingredient. So if you have these two ingredients in a triangle, then I will have two results. So one of the results will be parallel, and then another result will be MN is actually half of BC. That means this is 1 unit, this is 2 units. So the result is like what comes out of the ingredients. So if let's say you think about baking, so you got baking ingredients, so the result is cupcakes. So in any theorem, we will need the condition. And then if I got this condition, this will be the results that follow. Okay, so you must understand this idea first. And if we are going to say converse of midpoint theorem, then it will be the other way around. If you have the result, then that means it implies the midpoint. So that is called the converse of midpoint theorem. So if you want to apply the midpoint theorem, you must have the condition, and this condition give you these results. However, in some situation, you may have the parallel line, you may have the ratio, then it will imply the midpoint. That one is called the converse of the midpoint theorem. Okay, so see in this way, you organize it in this way. Actually, that's how I remember the theorem.